We're probably entering the golden era of clinical decision support for doctors. You see it everywhere. Epic, the largest EHR in the US, is rolling out a roadmap of features. You have startups raising a ton of money, getting clinical decision support tools in front of doctors. You have AI scribes. But all of the hope of these tools might be crushed if they have the opposite unintended effects. Hey everyone, and welcome to another episode of Paper Pushers. In this series, we highlight clinical AI research and applications, so you have the tools and frameworks to make radically better healthcare solutions. I'm Sahej. I work as a product manager at a healthcare startup in India. I trained as a doctor and a bioinformaticist and have worked on clinical AI deployments in the US and in India. Today, I'll be talking about a paper called AI-Clinician Collaboration via Disagreement. The authors of this paper redesigned the CDS system for chest X-ray analysis. Why? Well, the authors are trying to tackle the real-world safety risks that come out of deployment and try to make these systems better. What exactly do I mean? Well, imagine that you're an airport agent trying to scan bags for dangerous items, kind of like a radiologist who has to scan chest X-rays. Well, suppose that you get a fancy AI tool that helps you detect things better. Are you better and faster at your job as a result? The answer is it depends. The system might be wrong often, which you grow tired of and ultimately start to ignore its alerts. Or the system might be right often initially, and you basically hand over your duties and let it do all the work. You can see how both of these situations create safety risks. Not to mention, they defeat the whole point of having a human in the loop and collaborating between AI and human. You don't get the best of both worlds. CDS in radiology behaves a lot like this example. And studies have shown that clinicians do start to over-rely or ignore these systems. The authors of this paper come up with a clever setup to change things up a bit. They present the alerts and predictions of the chest X-ray analyzing model differently based on certain additional factors. For each analysis or prediction that the model makes on the chest X-ray, they also predict how clinically significant it is, as well as whether the AI and clinician will disagree. So they've added additional models in that pipeline of clinical decision support. And what this allows them to do is present the alerts in a more smart and structured manner. So for predictions that will be agreed on as per the system, they just automatically include them in the radiology report if they're present, or hide them without alerting if they're not present. For the predictions that the system thinks the AI and clinician will disagree on, well, it tags it for needs review if that finding is clinically significant, or it just shows it for quick access if it's not very clinically significant. So to really understand it, let's look at the UI of the before and after of this system. So what you have here is actually a UI screenshot that I was able to find on the internet of the tool that they're actually trying to optimize. You see the chest X-ray on the left side, and you see the AI system's alerts on the right side. So in this case, the AI thinks that there's pleural effusion, widening mediastinum, atelectasis. These are basically just clinical findings that the AI and the radiologist are both looking for. Now, you can imagine some of these are right, some of these are wrong. The radiologist has to click on each of these to accept or reject them. And maybe the ones that the AI did not find, it just hides them in search finding, and the clinician or the radiologist doesn't even think to or remember to look for them. Now, here's the new system. This is not actually the UI. I just combined in a Frankenstein way the old picture with an image from the paper. What's changed is the right panel. You have these 4 sections. auto include, review required, quick access, and search finding. So what's happening here is that whatever the AI model sees as present in the chest x-ray and thinks the clinician and AI will agree on, it automatically includes. It's in the auto include section. For the findings that it may not have seen or has seen, but thinks the clinician may disagree on, it highlights them for review required, and the radiologist has to act on them. The remainder of the findings, for example, the ones which are not present and will be agreed on, are just hidden away for search if needed. Ones which will be disagreed on but not clinically significant are just there for quick access. So the clinician or the radiologist doesn't have to remember. They can just go with the AI system's judgment. So you can see how this could potentially add work or reduce work. The authors simulate basically the UI burden, the cost of selecting, finding, searching, reviewing images, and they compare the new system to the old. And they find that the new system can potentially save radiologists' times, as well as having balanced the safety risks. I think that's really great. I think it's clever. It doesn't look like much on the surface, but what it highlights is the potential when you have clinical decision support not powered by just one model, but by a system of models. These sort of safety risks are well known in academia, but I don't see them discussed as much in industry. And I think as we deploy new and more powerful clinical decision support systems, we need to think in this way. You already see a lot of people talking about how we need to move from one model AI systems to multiple model AI systems. You also see in generative AI agents, you have multiple agents working together to complete a task. So I think there's power here, and I think it's worth paying attention to. I haven't gone over certain sections, which I found also compelling in the paper. I would encourage you to read the paper for the details and those sections. And I hope that in the future, as we develop these systems, we set up the human in the loop for success. Thanks for watching the video, and catch you in the next episode. Thanks so much.